solving for the argument and absolute value of a complex number from polar form. So, here's my new whiteboard. New setup, we have a little tray for markers and the eraser. And yeah, so let's start. So, polar form. What is polar form? Polar form is a way of representing complex numbers such that we have z equals a plus bi, but we can convert this to z equals r e to I theta, where r equals absolute value of the complex number z, and theta equals arg z. So, we can write z as absolute value of z e to the I arg z. This is also called the mod arg form because we have modulus argument. So to solve for arg z, we have to divide. Here, we'll do it over here. Solve for arg z. Solve for the angle arg z. So to do that, we divide both sides, so we get z over modulus absolute value of z equals e to the I arg z, and then we take the natural log of both sides. Natural log of z over absolute value of z equals I arg z, and then divide both sides by I to get negative I ln z over absolute value of z equals arg z, or you can also write arg z equals negative I times ln of z over absolute value of z. And there we have it. And you might be wondering how we got negative I from dividing both sides by I. That's because if we have, for example, here, if we have x equals iy or something, and then if you want to solve for y, you need to divide both sides by I, right? But then you might realize that dividing both sides by i's cross out, and then what is this? X over I. So you can multiply both sides by I over I, since I over I equals 1, right? And then this becomes negative 1, and then here we have I. So the negative 1 just moves over there. Dividing by negative 1 is like multiplying by negative 1. So we have negative ix equals y. So yeah. And also, here we have a equals b. So that implies, these are equivalent expressions, that b equals a equals b equals a. The property of equality. So now I'm going to solve for the absolute value of z. So solve for absolute value of z. We have this formula right here. Right? So now all I have to do, well, is divide by e to the I arg z. So you get z over e to the I arg z equals absolute value of z, and of course absolute value of z equals z over e to the I arg z. Alright, there you go. So now we have formula for the absolute value of complex number z if we know the argument, and the argument if we know the absolute value. So that provides a nice connection between the argument of a complex number and the absolute value of a complex number. And yeah, that's basically it. So hope you liked the video. See you in the next one.